Well, hello everyone. Welcome back to Adrian's Digital Basement. On today's video, I'm going to be trying to repair the floppy drive in this old barn-found Apple IIc. There was a recent video on the main channel where I looked at 4 Apple IIcs. They were all found in a barn and were super filthy, and I won't spoil anything that happened in that video, but I will say that with this machine, the machine itself works, but the floppy drive does not work. So in this video, I'm going to do what I can to try to get this floppy drive working once again. So without further ado, let's get right to it. So on Apple II machines, all the 5¼ disk drives on all Apple IIs, from the very first one to the Apple II GS, they work in the same way, and it's different than the way they do on PCs. The controller that's on the drive is far simplified from the one on Shugart drives, and that's because a lot of the complexity of the disk controller has actually been moved to software on the computer. So it's software that's responsible for generating the correct signals that causes the stepper motor to move the head assembly around. And that's different than on the Shugart drives, where that is handled on the PCB on the disk drive itself, and there's very simple signaling that comes from the disk controller on your host computer that tells the heads to move around. That means the steps you need to take to troubleshoot the disk drives can be a little bit different. But one thing we have going for us though is that the actual controller PCB that is on these disk drives are very similar across all of the Apple II disk drives. This is the Apple IIc disk drive, which has the most condensed version of this board because it has to be super low profile and fit, within the case of the Apple IIc. But it's very similar to the ones that are on all the other Apple II disk drives, all the way until the ones that were sold at the very end of the whole Apple II line. I went and removed the cover from this disk drive here, which is the type that was sold with the later Apple IIes and the Apple II GS. And this is the cable that goes with it that plugs into the external connector on those machines, including the second disk drive connector here on the Apple IIc. What's really helpful though is that the connector that goes to the motherboard, which is this little ribbon cable right here, has the same pinout as the connector that goes to the cable that plugs externally into the disk drives. In addition, the mechanism you can see in this disk drive, which you can't really see that well, is the same mechanism that's used here. It's an Alps mechanism, which happens to be the same mechanism that's used on the Commodore 1541 disk drive as well. Of course, the electronics are different on it, but at least the mechanism is similar, including the read-write head assembly. That means if you have a IIc that can't read disks like this one can't, you can take a disk drive from an Apple IIe and you actually connect it directly to the motherboard on the internal connector and then attempt to boot the system. Of course, one of your problems you're going to run into is the little ribbon cable here is a bit too short, so you can use a longer one if you have a Macintosh or something, or you can make your own to connect this drive right up to the internal connector on the motherboard. And yes, in case you're wondering why I have these weird keys on this keyboard, that's because this machine, which was one of the 4 barn-find machines, had an Alps keyboard like 2 of the other ones, and I essentially swapped keys around to make 2 complete Alps keyboards, and this ended up being the one that had the most missing keys once I had stolen stuff off of it. So these keycaps actually come off of a Dell Bigfoot keyboard, which is also an Alps board. And the Bigfoot board I have is in really sad shape with a bunch of rust on it and a whole bunch of missing keycaps. I was given it in pretty sad state, but I use it as spare parts basically, and I can steal the keycaps off there to make this Apple IIc at least typable. And if there are any bad switches on this keyboard, which I'm pretty sure there are, then I'm going to steal some of the switches off this thing. Now let's look at the way that this disk drive is designed, and keep in mind that it's very similar to the way the IIe disk drive is here, or whatever this one's called, Apple Drive 5.25, and is also very similar to the very first Apple II disk drives that came out on the Apple II, II Plus, and the IIe. So this controller mainly handles the reading and writing from the disk. So it has the differential amplifiers that will amplify the signals and then convert them into a digital signal that can be sent over the cable down to the motherboard. The read-write heads, and it's just a single-sided unit here, has a single cable that makes its way over here and plugs into the PCB. You need to make sure that that is connected. And if we flip this little thing up here to take a look at the heads, there's the read-write head right there. It's that white thing with the line through it. You got to make sure that's clean. If it's not clean, a little cotton bud with some IPA on there usually goes a long way to cleaning it. We could see a lot of dirt and stuff in this drive, so could be dirty, but I already cleaned the heads once before when I was testing this machine earlier, and it didn't fix the problem. You also need to make sure that there's a little pad right there on this lever that pushes down on the disc, because you need a little bit of pressure to push down on the magnetic material as it speeds past the head so it can properly read it. If you ever looked at an audio cassette, it's very similar, and there's a little piece of felt inside the cassette itself. And when you hit play on your cassette drive, it moves the heads up into the tape, and that little felt thing has a spring on it, and it pushes the tape as the tape is moved past the read-write head. Works in a very similar fashion here on the floppy drive. So if you don't have the correct spring tension on here, you're definitely not going to be able to read anything. This connector right here connects to the other things that are on the drive. Most of them are on the bottom, but there is the write protect switch right here. It has a little sensor, it's an LED, and there's a little optical sensor on the backside, and that makes its way back to this so that you cannot write to the disk if the write protect tab is open. So there's a signal coming through here, then you can't write anything. But this has no effect on the reading back of the floppy disk at all. This is the top of the spindle motor, which is actually what's turning the disk. It does have 4 wires onto it, but these don't go up to this PCB. They actually make their way to this PCB, which is the speed controller PCB. So this has an adjustment right here, and it uses the tach signal on the spindle motor there to ensure that you're hitting the correct speed. If you live in a 50 or 60 hertz country and you have some flickery LED lights above you, when you run the drive, you can make sure you're running at exactly 300 RPM by just simply looking at this pattern. In the 60 hertz country where I live, these lines will just sort of be solid and not moving if you're at the right speed. If you adjust this, you'll see that they start to kind of move this way or that way slowly, and you want to dial it in until you're right on the mark, and these are exactly at 300 RPM. You can also use a piece of software to help you do that as well if you don't want to open up the drive, or you don't have that sticker anymore, or of course you don't have any flickery lights like I happen to have in the basement here. But yeah, that's a quick and easy way to do that adjustment. The speed controller just gets a signal that comes from that PCB on the top side to turn itself on, and that starts spinning the spindle motor here, which through this belt will spin the actual spindle. So you need to make sure that this spins freely and it doesn't have too much drag, and you need to make sure that that turns fine and it doesn't have too much drag. And you also got to make sure that you have a belt that works and doesn't have too much drag. To put this back on, all you do is just sort of thread it on that part and just turn it like that, and there you go, it's on. These generally don't break, they're fabric reinforced, and they seem to be super duper robust. Maybe there'll be a time in the future when these start to fail, and then we're in trouble. This is the stepper motor that moves the read-write heads, and this does connect back up to the PCB on the top side, and it is the motherboard and the software that is sending the signals to this to move this back and forth. Now, when you take a look at the stepper motor here, you'll notice that there are 2 screws here, and this has some glue on it, and if you loosen those, it allows you to twist this, and if you do that, it changes the alignment of the floppy drive. I highly recommend that you do not do that unless you know exactly what you're doing on how to get it realigned again. And to do so, you're going to need a disk that was written in another drive that's properly aligned so you can compare the reading and writing back of the drive that you've adjusted to try to get it back on track. I've worked on many floppy drives, including lots of these Alps type mechanisms, because these are found in Commodore drives as well, and personally have never run into any that were out of alignment. So I really don't recommend going directly to start adjusting those if you're having problems like this one's having reading disks. If you just jump right to the conclusion that it's an alignment issue, you're going to potentially create a new problem that the drive doesn't have. It's better to start troubleshooting other things first, like we're going to do in this video, to try to see what the issue is before we jump to any conclusions that it is potentially an alignment issue with the stepper motor. Now there's actually another thing that can screw your drive up really badly, and it's this right here. And if we move the heads back and forth, you'll see there's an end stop right there, and that is the track 0 end stop. And if you loosen this little screw, which is glued in as well, it will move this little plate and it will allow this to move more or less than it does right now. And that will affect the overall alignment of the entire disk drive. So I really also recommend do not loosen this screw, because you will be in for a world of trouble trying to get this stuff all back into alignment, especially if you're trying to deal with a drive that's not reading it and it's some other problem like a logic issue or potentially some bad read-write heads that are causing your issues, and you're just adding extra problems by loosening those screws. Now on this drive specifically, I know the heads are clean because I cleaned them. I also lubricated the tracks here so the heads move very smoothly, so that's not the issue, because if those are gummed up, then that's obviously going to cause an issue. And I also know for sure that the Apple IIc here has no trouble reading disks, because when I had the 4 machines on the bench and I was working on those barn find computers, I plugged one of the other disk drives that was working into this, and it was able to read no problem. All of the drive controller stuff for an Apple II is condensed onto this one chip right here. It's called the IWM, or Integrated Waz Machine. And if that chip does go bad, well, then you're going to have trouble reading any disks. And it does happen. I've heard reports of that chip going bad. And what's really unfortunate is there is no replacement that I'm aware of right now, other than harvesting it from another computer, like an Apple IIgs, it's a service mount one, or another IIc, or an older Macintosh boards. A bunch of the Macs, the early ones, also use a chip that's compatible, and you should be able to swap it out. but you'd have to kill another machine or render its floppy drive unusable to get it working in here. So keep your fingers crossed if your 2C can't read disks, and it turns out that no matter what disk drives you plug into it, it can't read them. Well, that's an indicator that you might have an issue here on the board with this chip. You could also have a problem with the connector on the back of the machine here. This one's all rusty, but I think it still works. We'll figure that out, I guess. Or maybe you have a power problem that's also causing trouble. So once you rule those things out and you tried different disk drives and you still can't read on the machine, then it's most likely going to be this chip. But luckily for me, I know that this motherboard is fine, so the problem lies in this disk drive mechanism itself. So I think the first thing I'm going to do here from a troubleshooting perspective is I'm just going to put the original drive back in the machine. And that's because people might be coming to this video some point in the future and will not have seen the repair video on these Apple IIcs. And I just want to double check that this drive still is broken. This goes to my RGB to HDMI, so we're not going to be using the regular composite output. It just makes capture easier for me. And I'm using a third-party power supply. It's not even really a third-party power supply. It's just this 12-volt, 4-amp power supply. And I built a little pigtail here that just plugs into it. It's just a DC barrel jack into the standard DIN. And if we turn on the computer, there it is. The drive seeked. It did the head bang as normal. Sounds correct. And it stopped accessing the drive as well. And when we take a look at the output of the computer, check disk drive, absolutely normal. That is exactly how it goes. I'm going to insert this disk here, which is the piece of software called Locksmith, and this is what I'm going to be using for testing these drives. There are a bunch of different pieces of software you can use for doing this. I like to use this one. It's just simple and basic and usually does the trick for me. So I'm going to do Open Apple Control Reset. And there we go. Nothing's happening. So out with the non-working drive, and what I'm going to do is I'm going to connect this Apple IIe disk drive here, where I've removed the cable already, to the 2C's internal drive connector. And the reason why I'm doing that is it makes it much easier since you cannot boot from the second disk drive on almost all Apple IIcs. Only the very earliest ones is that possible, and this is not one of them. This has the later motherboard with the RAM expansion connector. This ROM cannot boot from the external floppy drive, hence the need to use this 2E disk drive here. So in with the Locksmith disk again, on the second side that is. There it is, it's working fine, and it's seeking, so it's booting up. And here we are in the Locksmith tool, and I really like this thing because it's just very simple and it does what I want. So the U key there, 16S utils, we hit U. It's not working. Oh, it did work, okay. We're gonna hit V for verify. Input drive 1, so drive 1 or drive 2, so we don't have the second drive connected right now, so we're just going to do drive 1 so I can demonstrate and hit space to continue. Oh, you got to be kidding me. So I knew this keyboard had issues. I knew there was a couple switches that didn't work. Oh, okay. Well, I was going to say it seemed like the spacebar is having issues, but it worked after enough pushes. All right, so this is normal. This is what happens when you read disks. It's essentially doing a very quick scan of the whole floppy disk, and it's going to tell you if it's having any read errors. Now, it did have one little error there with a D. I'm not too concerned about it. I know that for whatever reason, whenever I make Locksmith disks, there's always like the odd sector here or there that doesn't seem to work. And if we read this again, oh, this is really annoying. Let's see if it comes back and has an error in the exact same spot the second time. Yeah, I think that is in the same spot. It was on 6. Let's just try that one more time. Spacebar seems to be functional now. Could be that this disk just has a bad sector on it. Yes, D, it's in the exact same spot. Now, if you're having issues with, say, alignment or some other problems, then you're gonna have tons of bad sectors all over the disk here. And I specifically use this screen to run these types of floppy drives through their paces. And if you are doing an alignment, for instance, or using a known good disk, you can loosen the screws and turn this and keep redoing this process until you're getting full reads all the way across. Or if we're having other issues, like maybe pressure on the heads here or the read write head and stuff like that, then this is very helpful to be able to tell us what the issues are. There are a bunch of other utilities in here, like you can do disk speed, so you can calibrate stuff. There's scan disk. This is another useful utility here. What it's doing is it's showing you like a visual representation of the sector format that's on the drive. Now, since Apple IIs don't use an index sensor, they have this sort of spiral pattern. It's not this consistent sector pattern that happens all the way across the disk. So this is another useful way to be able to see if your disk is reading properly. I went and grabbed a random floppy disk that I think is formatted for the PC, and we're gonna see what happens if we do the scan on this. How do we do this again? Here we go. Let's see what happens. Start, come on. Really? Spacebar worked and now it's not working? I'm going to do a quick interlude here, and I'm going to steal one of the key switches off this keyboard, and I'm going to swap it onto this one, because the spacebar not working, very aggravating. All right, one removed bad key switch later. I have the one from the Bigfoot in here. We have no trouble with that spacebar now. There are probably other keys that don't work, like the colon key, but I don't think it'll matter for this particular testing. All right, back in Locksmith, I'm going to hit Q. We're going to do a scan again on this disk. This is the Locksmith disk itself. So see this pattern here? This is what you would kind of expect. I'm just going to turn off the color decoding since that's not really necessary here. You can see that the dots look as they look, which is pretty normal for an Apple disk. We're going to stick in this rando disk here, and we'll read this again. And this is what we got reading this disk. And this just might be a PC formatted disk. Let's try the back side here and see if that looks any different. Yeah, I think this one's pretty much blank. And I wouldn't be surprised if this disk was one of the ones I was testing with when I was working on that PC single-sided floppy drive on a recent video. I think it was like a few videos ago on the main channel. So the backside here is just not even used at all. And you get that solid white. Going back to an Apple floppy disk, let's try side one, which is the Apple II desktop. This is a ProDOS disk. So ProDOS, I think, is going to look basically the same as a Locksmith disk. And the Locksmith disk is more like a DOS 3.3 format. And ProDOS, I think, just basically looks the same. The pattern of dots looks slightly different, but when you see this, when you use the scan disk function in Locksmith, you know you're reading the disk properly. And we'll do verify here under 16 sectors. And oh, it wants the Locksmith disk again. Yeah, sometimes this program needs to load a little bit of code. And there we go. Now we can flip back to the other disk. And so this is Apple II desktop. I'm assuming this won't have a bad sector. No. So good. That's a nice, quick, solid read. So this drive just confirmed working perfectly. All right, so for troubleshooting this non-working drive, I need to connect this up to the cable I took off this Apple IIe disk drive, plug it into here, plug it into the external drive connector so we can boot Locksmith and then do the testing on this drive. We can just connect this up. It's easy peasy, and the cable is keyed there, so you can't put it on the wrong way. And well, this is a little bit crusty over here, so I'm going to put some Deoxit all over this connector because it is rusty. All right, so this drive is connected up. If we power on the machine, hopefully no smoke comes out of anything. Here we go. Okay, nothing bad happened. Let's put the Locksmith disk in here. Let's press U. Really, the U key doesn't work very well either. Now what we can do is we can move this disk, and we're going to put the Apple II desktop disk in here since we know that that one reads perfectly in this drive. We'll put this in here. We're going to do drive 2. So slot 6, drive 2, that's the 5¼ inch disk drives here, and hit space. Okay. Looks like it's just getting a whole lot of nothing. Now, interesting is it does seem to have read at least a sector there. It looks like 00AA read, but I think D means that it's super unhappy. What I'm going to try doing here is it's adding a little bit of pressure here to this pad. See if that makes a difference at all. It makes no difference. No. This thing is just not reading at all. Now, if we lift this up altogether, carefully, it's definitely not going to be able to read anything. But it definitely looks like it's not reading anything at all. Let's move the connector around for the read-write heads. That's not helping at all. What we can do while this is reading, though, is we can flip this over and check the drive speed. We can see right there that it is running at a nice 300 RPM. I guess it's running a little faster, a little slow, but that is not enough of a problem to cause any kind of issue. So we've confirmed here with this utility that this drive definitely is not reading anything properly, but it's reading a little bit. And I say that because if we just take the disk out entirely and we do that again, what's going to happen, it's going to do that. So it's able to sense that there's some kind of signal, but obviously only occasional sectors actually read properly. And we'll try that one more time here. Oh. Wait, what's happening? It's suddenly reading better? I didn't even do anything. I just put the disk back in. Now, what if this is just dirty heads? Let's try cleaning this a little bit better. So what I'm gonna do for cleaning, and I found this actually helps, is I'm gonna use some Windex here, and I'm gonna put a little bit of it on this little swipey thing here. It just makes cleaning a little bit easier. And we're gonna turn off the computer since you can move the heads easier when the computer's off. And I'm just gonna go to town on the head there, and just with the Windex, which is soapy, of course, see if that helps at all. I don't think this is a problem with the dirtiness, but you never know. And then to finish up the clean, I'm going to use a little 99% IPA here on a cotton bud. And yeah, this came off 100% clean, so I just don't think that that's the issue here. I'm gonna use a little compressed air just to dry the heads. Just gonna make sure that the disc didn't get scratched or damaged being in that drive. No, it looks absolutely fine. So we're gonna boot back into Locksmith and go back to verify. It does a little bit of a load. Drive 2. Really, the 2 key doesn't work as well. Wow. Do that again. Yeah, 2 is another bad switch. Come on. The switches kind of come and go. I have a feeling there's like dirt that's on the underside of the keycaps and it like falls into the switches. All right, well, I think it's time for another interlude here. I'm gonna go and I'm gonna swap out the 2 key and the U key. Both of those aren't working properly either. All right, we're back after swapping out 2 more switches. Let's turn this on. I think the switches that are on the Bigfoot aren't clicky. They're the tactile, I think it's called. I don't know, they're much more quiet. So kind of interesting. I mean, kind of fun, I suppose, to convert an entire keyboard over to the tactile switches that are on that, just to get away from the clickiness of these. I like clicky, but I also don't like clicky. I prefer the tactile type. The 2 key works now very easily. Let's go back to this drive here and let's just see after that cleaning that I did that make any difference whatsoever? If it did, this is kind of a boring video, I suppose. No, what's happening here? Well, still having issues though. Clearly it's still having issues. But compared to that first time that we actually tried to load something, it's working better. Now I'm gonna push on areas of the board here. Well, actually, let's try moving the connector here that goes to the read-write heads. I don't think that's the issue. If there were a bad connection here, just moving it around would have made it work a bit better. It's really struggling on the later part of the disc. Now the thing is, the head starts reading out here on the outside track. Well, we'll use this disc as an example. It starts reading on the outside and it stops here. And you have to remember that as the disc spins, the disc is moving more quickly on the outside track. And with magnetic material like this, tapes or discs, when it's moving faster, there's a stronger signal. And as it gets closer to the inside, the signal gets weaker. And it seems like this drive, it has trouble reading the inside tracks, but the outside tracks are working. Let's try one more time here. I mean, what's happening here? What is happening? The drive is fixing itself in front of our eyes, and I'm not even doing anything here. This is ridiculous. Why? I mean, what is it? If we try this like 3 more times, we're gonna get a full disc read with no errors? The funny thing is, it seriously is. It's almost like on the next read, it's gonna have no trouble and just read the whole disc perfectly. What? I'm very confused at what's happening here. One more time here. Locksmith is not a very big program, so I have a feeling this will boot the computer now, reading the disc at this point. I've never seen this problem before. Why don't we switch to the other side? This is the actual Locksmith disc itself. It had the one bad sector, remember, when read with the 2E disk drive. I've never seen anything like this. That's the bad sector. Now it's struggling. I had 2 bad sectors. This makes no sense. I haven't adjusted anything. I thought maybe we'd be adjusting the differential amplifier here, but no. It's completely ridiculous. This doesn't make any sense at all. No. Why is this working better now? This is so wild. I'm sorry. I'm very flabbergasted here. Well, there you go. To fix your Apple IIc disk drives, all you have to do is try reading the disk several times, and then it just starts to work. We got a perfect read. Do you think that if I let this thing cool down, like we turn this thing off and come back later, that it will just suddenly work again? That is not reassuring. I do not like problems like this that just fix themselves, because what's to say this drive won't just go back to its old bad ways again at any time in the future. Let's try this is the Locksmith side that has the one bad sector that this thing detects. Let's see what happens with this drive. 6. It was on 6. Yes, it's reading the exact same bad sector. Oh, and it's got one more bad sector now at the end there. What if we try it again here? Anyways, you can see why I like this program there, because you can just keep hitting the space bar to keep rereading the disk. And if you're using the oscilloscope on the drive, you don't need to keep doing something on the computer. It's very easy to keep restarting. Interesting that it keeps finding the two bad sectors. We might need to put the disk back in this drive and see if it hasn't failed worse. It's that same 6 every time, and now F. Yeah, 22 sector F. Okay, let's go back to here. Okay, U, which we can push now. V, drive 1. Here we go. Before we only got 6. There it is, and no other bad sectors. Oh, okay, it didn't have a bad sector there. So it's still slightly flaky. Funny thing is, when you have slight bad sectors on Apple drives, they're very tolerant of them. I'm going to, oops, that's what I didn't mean to do. UV1, let's just read the back side of this disk here, which always read perfectly, the Apple II desktop. Okay, looks good in this drive. And we're gonna escape UV2. And I'll try the 2C drive again. I may just stop this video and come back and then see if it's gone and failed again. Nah, this is really annoying. Really, really annoying. I don't even know what to do with this video. Should I put it out or not put it out? May try to do some differential amplifier adjustments on here, which you do need to use an oscilloscope to do. But I don't know. Still gets that bad sector on the last track, although it's instead of a D, it's a 4. I think it means it tried to reread it 4 times and then it actually got a good read out of it. So the drive is still slightly improving. I think D means, I think the manual would help for Locksmith, but I think D means it just can't read that, like it's damaged or something. But the 4 means that it tried 4 times there. It went to a 1, so only tried to retry once, and then it worked. Yeah, maybe now it won't get a 1 even, because it's fixing itself just by using it. I don't know. I can't explain what's happening here. Oh, we got an extra 1 somewhere else, and it went back to a 6. So it's slightly degraded still. So on drives like the original Apple II disk drives and then the 2C disk drive, but not this one, you notice there's 2 potentiometers right here, and this adjusts the differential amplifier, and this is the analog circuitry that's reading the disk, and then it goes through other stages that gets converted into digital, which then goes over the cable back to the computer. It's possible that these can get out of alignment, and then you will have trouble with the differential amplifier, amplifying the signal and reading, but you can see that they are glued down. And they have not been fiddled with. So it's not like these are, changed or anything. It's possible that maybe they're just dirty and they've sort of fixed themselves. But all the connections on this board look good. Now, what could explain it not working and then getting better and better? Capacitors, electrolytics. It's possible that these guys are bad. They're not leaking or anything, but maybe just from the use, they're starting to improve. They're not warm at all. There are lots of test points on here for testing various signals, which I thought we were going to be doing in this video. But in the end, it seems like the Apple II did not want us to need to do any kind of troubleshooting on this drive. I'd like to get it working at least as well as the 2E drive though, and not having there's a D. So it's sort of at the limit of how good this drive can actually work. Now, if we start the read process, and I'm going to push the head to get it out of alignment. So I moved it a little bit. And now it's just freaked out because it's trying to read the sectors, and sectors on the Apple II, you know, it knows where the sectors are. And now everything is just going to be A. And I think it's saying that the sectors that it's reading or whatever's coming back from the heads doesn't match what it expects. It's expecting to see specific sectors on specific tracks that it knows the head should be on, and now it's out of alignment. So generally when you have things out of alignment on the drive, when it does read, you're going to see A's like that because it is reading, it's just getting back something that it doesn't expect. But if we do this again, it's going to reseek to track 0, and now it's totally fine. Let's do a scan disk here, and we're going to do 2, and we're going to look at how this looks here. This is that visual representation of the disk data. I wish I had run this before the drive just sort of fixed itself, because I have a feeling we would have just had a lot of nonsense coming in here. Well, that pattern definitely looks fine. Let's go back to side A here, which is the ProDOS disk. We'll do this again. Now, the drive I used to write these disks were different. I think Locksmith I made on another Apple II drive using ADT Pro, but this disk here, the Apple II desktop, I think I made it on a Greaseweazle on a modern computer using a PC disk drive. And I think the fact that the drive speed was slightly different is why those dot patterns on this disk kind of go on the up direction, and on this Locksmith disk when we do it, they all kind of drift towards the down position. Pretty sure that that has to do with the original drive speed. Now I'm gonna try to manipulate the drive speed while this is running. So I'm causing it to have read errors there, obviously. So I'm making it spin way too slowly, and that's what you get if it's not running fast enough. Well, anyways, I don't know, nothing is really showing up as a problem. Now I think what we should do, and I'm gonna get this disk here we were testing with before, and we're going to format this in this drive, and then we're going to try to read it in this drive. So I think it's under U for utilities. We're going to do 16 sector format, space, output drive is 2. This is write protected, so I won't erase it accidentally. And here we go. I don't think this has a verify pass. I think it's simply doing a format, but I'll be curious to look at reading this back in the other drive here to see what it looks like once this is done. So first we'll do a verify in the second drive here, and we'll just look at what this looks like. Okay, so it's a valid Apple II disk now. It should not have any read errors in this drive because it's the drive that formatted it. It does not. And now we're going to do drive 1, the disk we just formatted. And it's reading it just fine. Yeah, wow, it has absolutely no issues reading whatsoever. So I think the only thing we can do at this point, I have the Locksmith disk back in here, is this is going to have a few bad sectors on it. That's the one that's just always bad. And then we have a little bit at the end here. And I'm really curious if we can try to dial this out of this drive and make it at least work as well as this Apple IIe disk drive. And what I'm going to do to try to facilitate this is I'm going to adjust these potentiometers for the differential amplifier. And I'm going to do it without hooking up an oscilloscope. I do not recommend you actually do this. This is just for fun. And I know that I can get these back into alignment using a proper oscilloscope. You really need to use an analog scope to do this properly. So like I said, don't do this yourself. But I think with a tool like this, what we can do is we can twiddle with these and then do this fast verify, and we'll be able to see it lose ability to read the disks, and then we'll try to get it back into correct alignment again. So I'm going to use a marker just to draw a little mark on here so I can kind of see where these are turned. And I think I already messed one of these up and turned it a little bit, so I'm not going to do anything with that. Let's see if this thing can still read anything. All right, I haven't messed it up so bad that it can't read anything. I think I turned it a little bit and then turned it back. Okay, so it's no worse than it was. And then what we're going to do is we're going to start the read here, and I'm going to turn this. I think I turned it to a point where it can't read now. Yep. So I'm turning it back, and now it's reading again. Okay, so this is the one that's on the left side, closer to the spindle here. Let's start this again. It's quite a lot of range where it doesn't really do anything. Okay, we got 2 bad sectors there, so it's definitely struggling a bit more now. I'm just trying to get to the point where the last sector that has an issue there reads without any issue, like the other drive, like this drive right here. And no, that made it worse. Now, if you could look at an oscilloscope at the signal coming off the heads when you turn these, you're essentially adjusting this waveform to try to get it looking as good as possible. And now it's, again, worse. All right, well, that's just back to how it was. So now I'm going to turn the other one here, which I also put a mark on, luckily. So we'll break the glue. Just try turning a little bit. Look at that. It read the disk perfectly now. And I just turned this one literally just a little bit like that. Let's see if that's repeatable. No, we got a 2 again, so I think that was just luck. Let's see what happens this time, if it's any better. Oh, yeah, so it is reading a bit better. I'll try turning it just a slight amount more. Maybe I've gone too far. Now, generally, these two controls interact with each other. When you're looking at an oscilloscope screen, you're seeing the waveform change, and you're trying to peak it as much as possible. And obviously, what we're doing here is not that, because we're just guessing by looking at what we're getting on the screen here as we run this read. But ultimately, we're just trying to adjust this so it can read this disk as good as possible. All right, we're getting good reads there. Let's flip it over and try the other side just to make sure it reads this okay. Now, unfortunately, this doesn't explain why the drive sort of fixed itself, which is very, very frustrating. Okay, I had no trouble reading that disk. Let's try the one we formatted in this machine. Works as well. Now, I went and grabbed a bunch more Apple II disks. These are all ones that I've made over the years. And this is really just to see if there's any more of these that have bad sectors or things that has trouble reading. Oh, that's because the disk wasn't in there properly. There we go, let's try that again. Yeah, I just want to see if there's any disks here that have trouble reading, and maybe we can adjust these controls a little bit to get it reading properly. And what we can do is compare the way this drive reads versus this drive, since I know this is a good drive here, and see if we can improve the drive any further. But we might be as good as it gets, because all these disks are reading without issue. How unbelievably frustrating. And I think I'm going to go through the rest of these disks, and I'm going to look for any disks that are problematic. Well, several hours have passed. I decided to just take a break from this whole thing and let it cool down. And you might notice that the keyboard looks a little bit less disgusting now. And you'll notice there's a big pile of key switches on the desk here. And that's because I decided to, well, off camera, I went through and tested all the keys and found that those ones didn't work. Replaced those switches with ones from the Bigfoot. Went through it again, found a couple more switches that were misbehaving, swapped them out again. I'll probably do a separate video where I try to figure out if I can find a way to fix these, maybe Sonic Cleaner or something like that. But anyways, the keyboard's working well now, and while I had it upstairs and I was having dinner, I at least cleaned all that filth that was in between all these keys. It's still dirty underneath. Like if I tilt it like this, down there, it's dirty, but you don't see that. The part you see here looks okay. So let's get everything reconnected to the computer here so we can see if the floppy drive has rebroken itself or is actually working. I'm gonna plug this back into the computer as the primary drive because, well, if it's working like it was, then we have no trouble booting off of it. And then we can do some further testing and stuff in the case like this. And incidentally, there are 16 key switches that I swapped out on this thing. That's how many aren't working properly. All right, so we're ready to boot up Locksmith here. Let's see if this thing is even working here. It freaking works. So the rest period I gave it had no effect on the functionality of this drive. So we're gonna do a verify here, and we can do drive 1. And it still works. I mean, this is absolutely ridiculous. Let's see if we have those extra bad sectors though. Oh, we got the 1 on the end there. So I ended up going through all of my Apple II floppies, and even some really old ones like this that I got with an Apple IIe I bought years and years ago, all are working. I found a few of them that had bad sectors, but then I was testing with the Apple IIe disk drive connected, and when it didn't work in the 2C drive, I would move the disk to the other drive, and it also wouldn't work. So that just meant that the disk itself had bad sectors. Let's try this Apple Writer 2.0 disk here. I think this one worked. I can't really remember now. It's working just fine. And this is a very old disk that was written on another computer altogether. It wasn't even the Apple IIc. And there's no issues reading this floppy at all. Let's try out a copy of Desoldering. This is a paint program that I used to use a ton of when I was a kid and I had my Apple IIc. It works better with a mouse, so I'm gonna plug this Macintosh mouse into the computer, but I don't think this Mac mouse actually works on Apple IIcs natively. Strangely enough, only some of these work properly on 2Cs, and I don't really know the rhyme or reason. They all have the same model number. This is obviously a later Platinum one. And if we reboot the computer, There's a good test of the floppy drive as well, see if it loads up this software. I think I did validate that this disk reads perfectly. We gotta turn on the artifact color decoding. So this program here is configured for mouse operation and professional file system, which I think means ProDOS. We'll hit enter here. It's loading perfectly. I really like how fast Apple II disk drives work. Yeah, okay, so it's not working correctly. So the mouse pointer kind of goes in strange directions. It doesn't follow, like, I mean, I'm not even touching the mouse and it's moving across the screen. Luckily, there are little adapters you can get to make this work. Now, I don't exactly know what's in here, but it's the M0100 mouse adapter for the 2C. So if you happen to have a Macintosh mouse like this one here, all you need to do is get one of these adapters, and to be honest, I don't remember where you get these. Someone gave this one to me. Connect this in between the mouse and the port on the computer. We have a functional mouse. It's interesting because I have a bunch of Macintosh mice that look exactly like this, and they work perfectly. Well, they're the older beige versions, but they work flawlessly. So it's very strange that sometimes they work and sometimes they don't. All right, so let's load a photo off the back side of this disk, which I think has some of the pictures on here. I remember when I was a kid and I loaded this, hooked up my TV to my Apple IIc, I was like, whoa, look at that color. It's pretty amazing, to be honest, right? Like, the colors just look so good. I think there's a way for us to view the picture full screen. There it is. To me, as an 11-year-old with my 2C, I found this picture to be absolutely dazzling here with Dazzle Draw. So that's really cool to see that again. And this was the other demo picture that comes on this disc here, which doesn't look as impressive to me, at least, as the butterfly, but still pretty cool. So of course, this is a paint program. So you go to paint and you have these colors available to you, and you can paint in color, and you have all these 16 colors available to you. And yes, it's using double high res, which means it only works on the Apple IIe and stuff like that. Even though this has a somewhat high resolution available to it, because it's using the artifact color, the effective resolution is still relatively low. It's like 100 something by 200 pixels down. And that's the only way you can get a clear representation of every one of these colors without all sorts of strange fringing. Mainly what I wanted to show is that this 2C really is working properly. I didn't really do a whole lot of testing in the barn find video, but now that the disk drive is just magically working, well, it does absolutely load software perfectly, and it's reading all the files off this disk, which is one I made ages ago using ADT Pro on some other computer. Let's try loading Fat City, which of course is a game that I absolutely always have to test. It's like my 8-bit dance party, but for the Apple II. And let's turn up the speaker here. It's normal. Oh, yeah, I mean, so the disc loaded, and the head banging that this game does seems to do it all the time, no matter what disk drive I have connected to. Okay, well, that happens when it does have trouble loading, and I have encountered that before. Let's just try this again real quick. See if it works better on another try. We had like those, oh, it's doing the headbangs here. So maybe the disk is misbehaving here. Yeah, or the drive, that is. Okay, there's a lot of loud headbanging. Let's go back to the Apple IIe drive here. I just want to make sure that there's no issue on this computer loading this particular piece of software. So Fat City into the drive, powered on. Okay. It loaded perfectly with no headbangs. So I think we still have a little bit of work to do on this floppy drive. Now you may remember when I was loading this game on the Apple IIcs on the barn find video, so I had all 4 of them, it did headbang once on those other 2Cs. And I'm quite sure on my non-barn found 2C, the one I bring out for testing all the time, this disk usually headbangs just once while it's loading. So it seems like 2C disk drives maybe just aren't as good as the ones on the Apple IIe here. These are just a little bit better. I think this is a more modern drive. The controller obviously seems slightly optimized. It doesn't have those adjustments for the differential amplifier anymore, and only has 3 ICs on it, while the 2C drive actually has 4. Now, one thing we can actually do is we can plug the mechanism from the 2C drive into this controller board and see if it behaves a little bit differently when this drive is connected to this board. I just snipped off the zip tie that was holding that on, and I just need to make sure that I get this correct. The orange cable is over there towards the middle of the drive, which I think requires flipping this over. And there we go. So it looks like that. Even though there's 2 extra rows of pins, they're just not used on this connector. All right, I think this is going to work. We'll just precariously balance this right like so on there. And first we'll turn this on, and hopefully we don't let the smoke out. Okay, see, it's working. And now we can stick Fat City in here, and we'll see if there's any kind of headbangs on the 2C mechanism plugged into the 2E controller. Ah, well, you know what's gonna not let it work? If I don't plug the read-write heads into the controller on there. I find it pretty hilarious how this is sort of wrapped around these components here on purpose. Like it's been tucked in between these little capacitors there. So we'll just free it up here like that. And we're gonna be connecting it up to this PCB in that position there. Now, the reason why this works, by the way, is the mechanism in the 2E drive, the Apple 5¼ inch drive, this one is an ALPS drive. It's exactly the same mechanism as this one. It's pretty much interchangeable, I'm pretty sure. So that's why it's all just gonna work like this. So I'm gonna hold this precariously like that, and we'll turn it back on again. And there it goes loading up. Interesting. It's headbanging. So I'm just gonna try that again. I think I had the bottom of the drive rubbing on this mechanism here. So I'm just gonna hold it so it's not rubbing. We'll try this again. Right, okay. Well, it did load that time with only a couple headbangs. This definitely tells us that there's something going on with this head assembly, more so than the controller itself. All right, well, let's think about what are all the possible differences between this mechanism and this mechanism. Obviously, we have a few different things. We have this speed controller and the spindle motor. That's different, but I don't think there's a problem there. I think that's all running pretty smoothly. We have the read-write head itself on both these drives. Maybe this one is slightly bad or messed up somehow. And then we also have the head alignment, which is the stepper motor on the bottom that I said not to change. Maybe that's the problem here with this disk, allowing this drive to read it perfectly, but this one to just sort of struggle ever so slightly. Now, the issue with loosening those 2 screws and trying to change the alignment is you really need to make sure you have a disk that is written on a perfectly aligned drive. And can I really trust any of these Apple II drives to be perfectly aligned? I said that this Apple IIe drive here seems to work fine, but I know that this floppy drive, which headbangs here worse than normal, is also headbanging though in all my other Apple IIcs. So is it possible that maybe I wrote this disk on this external floppy drive, and that's why it reads it perfectly, but in all of these 2C drives, maybe they're aligned correctly, and the issue is this floppy disk itself. So what I'm gonna do is I'm gonna take this blank disk and I'm gonna create a new copy of Fat City, and I'm gonna do it on my Greaseweazle, my lab computer up here. And that's because the 360K drive I'm using is a much more modern drive with a stepper motor that can't be adjusted by just loosening some screws. And of course it doesn't headbang either because it has a track 0 sensor. So I feel much more assured that the track alignment of that drive is far more accurate than the ALPS mechanisms in the Apple machines here. So we're just gonna drag fatcity.disk here onto here and then hit enter, and I think it's gonna start writing to the disk. Now you might be wondering, how am I doing this? I am using the Greaseweazle and I'm using Flux Engine, the command line version here. And I have these scripts that I wrote that just allow me to quickly, easily drag and drop. I'm gonna make a video all about the Greaseweazle soon, and I'm gonna publish all my scripts here and put them up on GitHub so everyone can access them, because it's a bit tricky to figure out all the different little ins and outs of these scripts and the command line parameters and stuff like that. And it makes it really easy just to drag and drop, just like you saw I did there. And with that, we have an Apple II disk that I just made on my modern computer with good alignment, and let's give this a try. So here we go. It's all super precarious. I'm just going to hold the drive so it doesn't touch anything. Okay, look at that. It loaded perfectly, and the sound is just turned down. So I think that just means that this Fat City disk was written in an Apple II disk drive that does not have good alignment, so it's not really trustworthy. As a final test, what I need to do is we're going to get this out of here and go back to the Apple IIc drive mechanism and controller board. So if you have a bad mechanism on your Apple IIc drive and you have a spare 2E drive and you like to get your 2C working again, you can absolutely take apart the 2E drive and use just the mechanism part here, swap over this faceplate here. It is compatible. You take the screws out, you can swap it over, and then the cables from the 2E drive will connect up to the 2C controller. You just screw it in there, and then you should be able to use the completed drive in your 2C to get it working. And that's if, of course, it has some major alignment issues or the read-write heads are bad or something like that. I don't know if I should reroute the cable here the way they did. I suppose you just want to make sure it doesn't like fall down and get stuck in this thing here. All right, so there's the new copy of Fat City in the drive, and here we go. There it is, loading perfectly with no head banging. Okay. Well, now I know that whichever drive I used to make this copy of Fat City at some point in the past has issues. And you know, for all I know, it was that drive that I did it in. So what this shows absolutely is that this mechanism is aligned correctly. There's no issues with it. And that YE drive up there, which I know is also aligned really well, coincides with the alignment of this drive perfectly. And that's really one of the reasons why I recommend not touching those alignment screws, because you just have to be absolutely sure that you have a drive that makes disks that are perfectly aligned that you can test with. So we're gonna do a verify on this disk again. This is the Locksmith disk, and then we'll do a verify on the disk that I just made on the PC. There's that bad sector, which we already know about. And look at that, no bad sectors. And let's pop in the new copy of Fat City I just made. Boom. Looks good, doesn't it? Looks really good. Now, in case you're wondering about using Locksmith for disk speed, it's also really, really good as well. There's 300 RPM normal and then optimum speed recommended. Let's just see if this thing is running at optimum speed. I don't know what that is. It's like a little bit less than 300, I think. It does erase the disk, but I just made this, so I don't really care. And we're gonna do medium adjustment first and number of samples per line. I don't know, we'll do 2. It takes repeated samples from the disk and then it graphs it. Now the dots that you see there are the various samples and they're all a little bit fast. As you notice at the bottom it says slow and fast. Now what's awesome is we can do optimum speed and then we can look at the graph scale. We'll go to fine graph scale this time and we'll do 2. And we'll actually adjust the drive speed here and we'll get that line right on target for whatever this optimum speed is. So I tilted the drive up on its side. Notice that didn't really have any effect on the speed. And then there's a little potentiometer on the bottom here. And I mean, I barely touched it. And look how much the line moved. Okay, I turned it so much that it's all the way on the far left side there. It's pretty difficult to adjust this potentiometer perfectly on the 2C drive. And that's because this pot is not a 10-turn pot. It's like a 1-turn pot. And therefore, there is just not a lot of range here. I may not be able to get this perfect. I'm just gonna let go. I guess that's a little bit closer. On drives that have a 10-turn pot, which is some of the speed controllers, it's actually a lot easier to get a much more fine, precise control. But this one, yeah, there we go. Problem is, of course, this speed controller is not super accurate. It's not like it's using a crystal oscillator to hit a perfect target like modern drives are. Therefore, temperature variations will cause it to drift and stuff like that. And the Apple is very tolerant of that. You don't really need to have the speed perfect, but there we go. I adjusted it a little bit. It's slightly slow, but I just wanted to show that this program is really good for this speed adjustment as well. Well, since this floppy drive decided to just totally fix itself and, well, it kind of ruined my whole repair video that I was going to be doing, why don't we get this drive spinning and poke around at the test points with an oscilloscope and just look at what these controls on here actually do. All right, so to get the disk spinning, so we can read the flux data off the disk indefinitely without having to have the computer time out like it does when we power it on there, we're gonna go into the machine language monitor and I'm gonna use a couple soft switches to get the drive spinning. So the soft switch to turn on the slot 6 disk drive is COE9. And that doesn't really do anything, and that's because drive 2 is selected by default. So now we go COEA, and there we go. Now drive 1 is actually spinning. And the oscilloscope is connected to this random test point right there. And if we put in this Locksmith disk, there it is. there is flux data. This is an analog signal being read right off the disk. Now, if you watched my recent repair video on the Tandon TM100 IBM PC floppy drive, you'll remember that if I was poking around trying to troubleshoot that drive, we saw very similar signals to this. In fact, we pop that disk out and I insert a PC disk here. This is an IBM PC formatted disk, MFM encoding. Notice that signal looks very, very similar. Now, if you looked at enough of these signals, you might notice the difference between MFM encoding used on PC disks here and the GCR modulation that's used on Apple II disks. Let's go back to the Locksmith disk over here. So notice this signal just looks a little bit different, and it's just the way the flux data is written onto the disk is slightly different. Now, this drive does have a lot of test points on here. Let's move over to this random one over here, and I just need to adjust the voltage scale there. And we are on AC coupling right now because I knew we were going to be looking at a low voltage signal. So this is more like a digital signal that's obviously being converted from the analog one we were looking at before into something that's closer to what the disk controller is actually going to be able to receive. Now, if we take this disk out and we go back to the PC disk, let's see if we notice the difference in the way the pattern looks. And it looks basically the same. And yeah, I mean, really, in case you were wondering, the disk drive itself can read PC disks perfectly. It's really the controller circuitry and software that's on the Apple II itself that's not set up for decoding MFM disks. Now, there were two test points right near each other, and this one looks like a very similar analog signal to the other one that we were looking at over here earlier. And then we have another test point that's closer to the output that goes to the computer, and it looks very similar to that one we were just looking at. This definitely is the digital signal that's making its way down to the motherboard. Now, when it comes to checking your drive alignment, there are lots of manuals you can go read about looking at waveforms on oscilloscopes and checking the alignment that way. I just wanted to give you a brief glimpse without being a really good tutorial because I don't really know what I'm talking about here to see what these waveforms actually look like when the drive is properly aligned. So we're going to just make this a little bit bigger so you can see it. And that right there at a 100 millivolts per division, we're getting about 500 millivolts peak to peak. If I move the head by hand off of the track, you'll notice that the amplitude went way down on that waveform there. And if I keep moving it here and we get back onto another track, there we go. See, it went back up again. So you can kind of see, I'm pushing the head ever so slightly, and in between two tracks, it's going to be reading crosstalk and stuff like that. You really want to have the strongest amplitude possible. So if this board on the disk drive had issues like that IBM Tandon drive had, where it was losing the signal partway through, we'd be able to look at the test points and actually see the analog signal here being read correctly off the disk. And then we'd see it lost along the way when it gets converted to digital and not making its way to the computer. I've actually repaired a couple Apple II disk drives in the past that had that exact fault, very much like that Tandon drive. I just hadn't made a video about those, unfortunately. So here's something that's pretty funny. I was fiddling with those two potentiometers on the disk drive, and this is the Locksmith disk that's in here. Let me just verify. Yeah, it's the Locksmith disk. And it actually is able to read the disk entirely sometimes with not a single error. Okay, it's gonna error out that time. It's odd because it just gets that one error occasionally, but on some reads, it's absolutely perfect. So it's actually working potentially a little bit better than that other disk drive. Although, look, now it's camera shy. I read it multiple times with 100% clean read and no issues, but now it's not doing it. Oh, okay, it got a 1 instead of a D. There we go. Clean read. The whole disk actually read cleanly. Isn't that awesome? Well, that's going to be it for this video. Really ended up being a nothing burger. I was really hoping for a fun diagnostic session on this broken floppy drive and we'd figure out what was wrong with it and get it working and a swap-in mechanism and stuff like that. But in the end, the drive just fixed itself magically, which is honestly the worst thing that could happen because I'm not confident that this problem is totally fixed. Maybe what I'll do is I'll just stash this machine away for 6 months and I'll bust it out in 6 months and see if the drive is still working or not. At least I was able to show that you can poke around with the oscilloscope on these Apple drives and see the signals and stuff like that and get a good feeling for the fact that it's reading a disk properly, and you saw what the good signals look like. So if you're working on a drive and you don't see those signals, then you know that you have some kind of issues. Unfortunately, with floppy drives, they are mechanical devices and there are a lot of variables that can cause them not to work properly. Not just the electronics that are on there, but the read-write head itself could be going bad. The mechanism that moves the heads around could be going bad. There's all sorts of potential problems with them. And that makes repairing them, unfortunately, pretty difficult. which is really one of the reasons why it's so great. We have alternative solutions like the floppy emu for the Apple II and all these smart port type devices that can let you boot Total Replay and play all the games and stuff without even having to worry about these silly old things. So if you enjoyed watching me fiddle around and flounder around with this thing and not do anything, then I'd appreciate a thumbs up. But if you didn't, you know what to do. If you know of any really good videos on fixing Apple II disk drives, I'm sure there are plenty out there. Definitely, well, I guess you can't put comments down below because if you put a link in a video, it will not work. What you can do is email them to me at my channel email, and then I'll add them into the description or put a pinned comment, something like that. So people can look to see an actual repair of an Apple II disk drive happening. I know there are videos out there showing you how to do the drive alignment, like what software tools to use and whatnot. In the past, when I have had to fiddle with the drive alignment, I always use Locksmith and that fast scan that we were doing there, just to quickly see, once I got all dots, I know I was right on target. Just like with this drive, adjusting those potentiometers, it's a really good way just to see if you're able to read disk properly, and then I could just go through a bunch of different disks and see if they all read correctly, which they are. This drive definitely appears to be working perfectly now. So that's it, all the usual YouTube junk, thumbs up, etc., and stay healthy, stay safe, and I'll see you next time. Bye-bye.